So the target is saying A and B are two events in a sample space. The probability of A naught, again, this one is probability of A naught, again. And then the probability of B, it's the probability of A naught is 0.45. The probability of B is 0.35. Okay. They say determine the probability of A or B if A and B are mutually exclusive events. Let's start with this way. What does it mean, mutually exclusive? What are they telling us? They're telling us what? The probability of A and B is going to be equal to what? That's where we start. Okay? And then we are going to use the addition rule. What does the addition rule say? It says the probability of A or B is going to be given by probability of A plus probability of B minus probability of A and G, like this. Okay? Okay, what are we looking for? We are looking for A or B. Okay? We can look for any one of them. Yeah, we can look for any one of them. Then. Now, we are looking for this one, so we're going to start with the one that we're looking for. So probability of A or B. Probability of A. Do we know what is probability of A? Yes. We don't know, okay? But can we get it? How do we get the probability of A? So we'll tell them which the probability of A is going to be given by 1 minus 0.45, which is going to be actually 0.55. Okay, what is going to be the probability of A? 0.55. Plus, this is 0.35, okay? Minus, what is the probability of A and B? It's 0. And then if you do that, what you get, my friend? It's 0.1,9. Okay, we're going to get 1, 2, 3. Let's give Papela a round of applause. They say determine A and B. We're not looking for A or B again. We're looking for A and B if the events are what? Are independent. Now, what do you understand by the word independent from what we've learned? What did we say about independence? So for independence, the probability of A and B is going to be given by probability of A multiplied by the probability of B. Again. Yes. Okay, let's go for independence then. Go and say 1.2 probability of A and B is going to be equal to the probability of A multiplied by the probability of B. Do we know what is the probability of A? And now we know again. What is the probability of A? 0.55 multiplied by probability of B 0.35. And then what do we get as the probability of A and B? 0.19. Now, let's take this opportunity and also teach Lena something. They could have said to you here, Stoffel, calculate the probability of A or B. They could have said calculate the probability of A or B. Okay? If the events are independent, calculate the probability of A or B. So if you want to get the probability of A or B, how do you get A or B? You get it by using the addition rule. Okay? What does the addition rule say? It says the probability of A or B. Okay? Probability of A or B is going to be given by the probability of A plus the probability of B minus the probability of A and B. Okay? Now, we know what is the probability of A. What is the probability of A? 0.55. Plus, what is the probability of B? 0.35. Minus 0.19. So if they didn't say calculate the probability of A and B, they said calculate the probability of A or B. First, you're supposed to get the end part. Okay? After getting the end, then you go and get the what then? The O. Okay, yes, Stoffel. Yes. How can I get 0.55? Agree? Here, Stoffel, they gave us the probability of not A. They gave us the probability of not A. So this thing here can also be written in this notation, probability of A not. Now, what did we say? We said probability of A and probability of A not, they complement each other. What do we mean when we say they complement each other? They add up to what? To 1. Yeah, but so we know the probability of A naught. So the probability of A is going to be 1. But we know this one, we don't know this one. So this one was given as 0.45 plus the probability of A. If you take this one to this other side, it says the probability of A is going to be given by 1 minus 0.45. So that one, it's clear across whether events are mutually exclusive or independent, it doesn't matter. Are we still together? Okay, let's jump to number 2 then.